Hi guys, hope you're well. Okay, so for this week, moving on with our elements topic, we are going to be learning about things called mixtures and compounds. So success criteria for this week. So hopefully by the end of this week, you'll be able to state what is meant by a mixture, state what is meant by a compound, and then give examples of mixtures and compounds. So not a huge amount there. I'm going to talk you through just now what tasks I would like you to complete in order to achieve the success criteria. So just a quick reminder, when you go in to your team, to access the files that you need for this week, you go to the files part here, then go into elements and periodic table, and you're looking for number 3, elements tasks week 3, the 1st of February. So everything you need for this week's in this folder. So if I open up your task sheet for this week, this will tell you everything I would like you to complete. So the first thing you're going to do is watch this video. That's your first point. I've then got another video that I found on YouTube which explains the difference between elements, compounds and mixtures as well. So it's worth having a look at that just to make sure you're happy with it. As usual, I've got a couple of worksheets. I'd like you to read through the information and fill in any blanks. And there's also a PowerPoint presentation that will help you with that as well. So you read through the booklet, I'll show you in a second, and you use the PowerPoint to help you fill in the blanks. BBC Bite Size has also got a nice couple of pages on the differences between elements, compounds and mixtures, so it would be worthwhile having a look through the pages on BBC Bite Size. And the good thing about that is that it's also got a little quiz that you can try to see how you're getting on. This week there's 2 things I would like you to do for me. One of them is just make a poster about the differences between elements, compounds and mixtures. So you can do this digitally on Word or even PowerPoint or Publisher, or you can do it on paper and then just take a photograph of it. And I'm going to get you to upload that to your assignments tab. And then as usual, I'll give you a little quiz later on in the week with some multiple choice questions just to see how you've got on with this week's tasks. So this Word document at the top, this is your booklet for the week, all about mixtures and compounds. So I'm not going to go through everything, but I would like you to have a read through the document, and anywhere where there is a blank, I'm going to see if you can fill out the blanks. And then what I'll do is towards the end of the week, I'll give you the answers and you can check. So in the booklet, it tells you about the difference between mixtures and compounds. And like I say, there's a few sort of fill in the blanks. So again, you can download your own copy of this to Word and type in the answers, or you can print it off and write in the answers, or you can just write it into your jotter. You don't need to submit this work this week. This is just for your notes. But if you do have any questions or you want me to check it, then feel free to either post them on the Teams page or to send an email to me with the materials. So a couple of pages there for you to fill out, 5 pages. And again, there is a PowerPoint here that you can have a look, which helps you understand the differences. I'm just going to spend about 5 minutes or so taking you through the differences quite briefly, just to get you started for this week. So far in this topic, we have already learned about what an element is. So we should know at this point that an element is a substance that has only one type of atom. Okay, so a kind of way to think about that is that if you had a packet of Skittles and they were all red Skittles, then you could say that's a bit like having an element because they're all the same. Every Skittle is red, so it's like the atoms are all the same. But what if it's not an element then? Because obviously we've had a look at our periodic table and that's not got everything in it. There's materials like plastic and wood that aren't in the periodic table. So what category do they come under? Well, that's where these 2 terms, mixtures and compounds, come into it. So if we are dealing with a substance that doesn't have one type of atom, so it's got more than one type of atom, then it is either a mixture or a compound. So what's the differences between these then? Well, I'll try and show you just now. So 2 diagrams here showing you what an element looks like. So again, think about your Skittles. If they're all the same colour, then that's an element. So in both of these, the one on the left, we've got kind of gold atoms, the one on the right, white atoms. And because they're all the same in each of them, then we have an element. That's what makes it an element. If we were talking about a mixture, we can see now that we have different colours of atoms. Now, I'll just point out atoms themselves don't actually have colours, it's just a way to think about it. But if we look at these pictures, we can see quite clearly there's lots of different colours here. So what makes this a mixture is that you've got different colours, so different types of atoms, but they're still quite separate. They're still sort of floating about on their own. So this would be like if you've now got a bag of Skittles with all the colours, but it's just in the bag. So you could pick them out quite easily. You could pick out the red, the green. So same idea with our mixtures. It's when we've got our elements sort of mixed together. So different colours, different types of atoms, but just mixed together. So that leaves us with a compound then. So a compound's probably the trickiest one to try and get your head round. But if I show you a picture, hopefully you can see what a compound is. So the first thing is that we should be able to see that we have different colours or different types of atoms in the diagrams. So straight away, it's not an element because an element's only got one colour. But it's also not just a mixture, because what you can see here is that the different colours are kind of stuck together. Okay, and that's what we mean by a compound. It's when the elements are actually chemically joined together. So it's not just like having a mixture, it's that they're actually combined together with other elements. So in the left one, you can see we've got a black atom, but there's 2 white atoms combined with it. They're stuck together. And on the right, we have a blue and a sort of goldy one stuck together as well. Now, a way to think about this with your Skittles is that if we were to take our bag of Skittles and heat them up, so put lots of energy into them, so we got a big sticky mess, would it be as easy to sort of pick out the colours then? No, because they would be joined together, they would be stuck together. And it's the same idea for our compound. It's when your elements are chemically bonded together. Now, it's not to say that we can't split them up, but it's not as simple as splitting up a mixture. So if you wanted to split up a mixture, normally it's fairly easy. You can either just pick it out, or depending on the substances you've got, you can sieve it out. Use a magnet to take out some of it, but it's normally pretty straightforward. But if we want to separate out a compound, because they're chemically joined together, it is really quite difficult, so you require a lot of energy to do it. So that's our differences again, so I'll just recap. Our element, one type of atom, so like one colour. A mixture is when we have different types of atom or different colours, but they are not chemically joined together. And a compound is where we have different types of atom chemically joined together. Okay, so the video that I've put a link to, and the worksheet and the PowerPoint all take you through the same as what I've spoken about here. So don't worry if I've went too fast, you'll have plenty of opportunity to recap this. But that's ultimately what I would like you to know by the end of this week. Now, the last success criteria was about being able to identify elements, compounds and mixtures. So obviously if there's a picture and we look at the atoms, then that's quite easy. But what if we were to know the names of some of them? Then how would we go about that? So if you were in the class just now, what I would be doing is playing this little game with you and getting you to shout out. But obviously you're not here, so I'm just going to have to show you how it works. So what we've got is we've got 3 tubs at the bottom, elements, compounds and mixtures. And we're going to have some materials floating from the sky, and we've got to decide which one that it goes into. So I'm just going to show you a couple of these just so you can get get an idea of what our examples are. So sodium chloride. Sodium chloride is a compound, okay? And I'll come back to that in a second once I do a couple. I'll show you. Iron is an element. Salad dressing is a mixture. Copper is an element. Lemonade is a mixture. Iron sulfide is a compound. Oxygen is an element. Carbon dioxide is a compound. Blood is a mixture. Methane is a compound. That's quite a tricky one. Sulfur is an element. Nitrogen is an element. Soil is a mixture. Ammonia is a compound. And steel is a mixture. Now, how you would know that, I'll just talk you through. So if it's an element, first of all, it's the same as lesson 1, the first week of this topic. If it's in the periodic table, it's an element. So you'll notice that nitrogen, sulfur, oxygen, copper and iron are all in the periodic table. So I wouldn't expect you to go as fast as I was there, but you would have your periodic table where you can check to see if it's in it, then it's definitely an element. If it's a compound, that's a trickier one, but the giveaway for a compound is that you can normally identify 2 elements in it. So working from the bottom up, sodium chloride. That's a compound because it's made of sodium and chlorine. So we can tell there that there's 2 elements present, but the IDE at the end tells us that they're chemically joined together. Iron sulfide. So iron and sulfur are chemically joined together. Carbon dioxide. Carbon and oxygen are chemically bonded together. Now don't worry about an ammonia and methane. They are tricky ones just because I set it to hard to make it go faster. We wouldn't really expect you to know that in first year, but they are special types of compound that you'll learn about later on. The giveaway for mixtures is it tends to be your everyday substances. Steel, soil, blood, lemonade, salad dressing tend to be mixtures, meaning that there's lots of different substances in them, but they're not necessarily chemically bonded together. So, like I say, I've went through this fairly fast. You will have the opportunity to read through all of your documents and you've got your PowerPoint as well. So, tasks for this week, just to recap, you should have watched this video, another video here, basically saying the same as what I have, but just to clarify. Fill in the blanks of your worksheets, go to bite size, again try the quiz, make a poster about the differences between elements, compounds and mixtures. Doesn't have to be anything too fancy, just a simple poster that tells me the differences, and you might want to include some examples in your poster, and then complete this week's assignment. As usual, first year, if there are any questions or if you have any issues accessing the materials, then please just put a post onto the Teams page, just here at new post, and just ask for help if you need it. Okay, good.